Hey, welcome to Unit 6, Chemical Reactions. And this is a super fun unit because we now get into some of the nuts and bolts chemistry type of topics. And in chemical reactions, I always say they're everywhere, from the products that we use like soap, from our ability to transport ourselves from burning fossil fuels, being able to grill our food with charcoal or propane, to reactions in our body to produce energy so that we can do our everyday tasks. So in this unit, we're going to talk about the 5 major types of chemical reactions. And there are many, many more, but that's what we're going to concentrate on. And my hope is that you'll be able to recognize the different types of chemical reactions, that you'll be able to discuss how chemical reactions improve our everyday life, and be able to balance chemical reactions if you're given a skeleton reaction, and to predict products of different types of reactions as well. So without further ado, let's get to it. So types of chemical reactions. The first, we'll concentrate on the 5 main types of reactions. And this is the first one, synthesis, or a composition reaction. And you can kind of think of this one as being like a musical composition. You make one composition of lots of different notes. And in this reaction, it takes the general form of A plus B is equal to AB. So here we have our reactants. You'll have 2 or more reactants making one big product. And our example here is one that is familiar to everyone, rust. So you have a metal, magnesium, in the presence of oxygen produces magnesium oxide. Of course here you could also have iron rusting. Iron plus oxygen equals iron. This would be iron 2 oxide. Notice here that this is what we call a skeleton reaction or skeleton equation because it is not balanced. We have 1 atom of magnesium here, 1 of magnesium here. We have 2 oxygen atoms on the reactant side, so we have to have 2 on the product side. And so to balance this equation, and we'll do more of this as we go along, you would have to put a 2 next to the magnesium oxide and then a 2 next to the magnesium. And now we would have a balanced equation. The same thing would with the iron. You'd have to have a 2 here and a 2 here to balance the equation. We call these things that we write in front of the symbols, we call those coefficients. And so coefficients are used to balance chemical equations. Like I said, don't worry about that too much now. We'll learn how to do that as we go along. Magnesium plus oxygen yields magnesium oxide. And iron plus oxygen yields iron 2 oxide. Notice here with the iron, it's a transitional metal. So when we name it, we need the Roman numerals. We did that in the last unit. Types of reactions continued. A decomposition reaction. Decomposition reactions are very similar to composition reactions, except they are in reverse. So here we have one big product breaking down into several reactants. One reactant breaks down into 2 or more products. And our example here is of potassium chlorate breaking down to potassium chloride and oxygen. This was one of the first reactions used to produce pure oxygen in breathing apparatuses for hospitals, scuba diving, welding, and so forth. So potassium chlorate breaks down to form potassium chloride and oxygen. We call this a word equation, okay? And this is just a regular chemical equation. So you can convert back and forth between these two, and it's a good thing to practice as you go along and practice your nomenclature skills from the previous unit. Types of reactions continued. Single replacement. And they have the general form of A plus BC yields AC plus B. So in this reaction, you have a switch of dance partners. I always like to kind of refer to this as students at the high school dance. Aaron is by himself, and Bob and Kathy are dancing. So Aaron replaces Bob, AC, and then Bob goes to the punch bowl by himself. So now Aaron and Kathy are dancing together, and Bob is by himself. So it's a single replacement reaction. It's important to note here that just because you mix chemicals together, they don't always react. And there's something called a reactivity series, and your teacher may familiarize yourself with those. And they have a series that tells you if things can replace other things. So maybe, for example, in this reaction, Bob and Kathy are going steady, and Aaron asks to dance, but Bob won't let Aaron dance with Kathy because they're going steady. So the same thing is true in chemical bonds. Sometimes a bond is so strong here that it will not break. We'll assume in our lessons that all these reactions occur. That will give us lots of practice in writing them. Okay, so we have one of my favorite reactions that we used to do in our chemistry lab was have zinc metal and pour hydrochloric acid over it to produce hydrogen. And we'd pop the hydrogen in small test tubes and that kind of thing. You should never do any kind of reactions unless you have adult supervision and have all the proper safety equipment. But in this reaction, hydrogen is +2, hydrogen is +1, and chlorine's -1. So the metals will replace each other. So zinc will dance with chlorine, become zinc chloride plus hydrogen. Here I have the equation balanced quite nicely. Oh, this is a picture here of hydrogen gas in our universe, or ionized hydrogen in our universe, in the Triangulum galaxy, I guess they call it. And this is a picture from the Hubble telescope. If you ever get a chance to go online and just Google Hubble telescope images, they have lots of nebulas and all sorts of cool images of the deep confines of our universe. Neat. Zinc plus hydrochloric acid equals zinc chloride plus hydrogen. Notice here in this reaction, hydrogen's a diatomic element, so it's written as H2. And then going on, we have types of reactions, and our next type is double replacement. So the same scenario applies, except two things change place. Take the general form of AB plus CD, and A will dance with D and C will dance with B. So it's two couples changing place. The metal will always be written first in these reactions, and then the non-metals second. So you can't have two metals combining or two non-metals combining. It's always metal by non-metal. So here we have hydrogen, which forms a +1 ion, and chlorine, which forms a -1 ion. Again, sodium +1, hydroxide -1. So hydrogen will dance with hydroxide, okay, and sodium will dance with chlorine. We did some of these reactions in the previous unit. These are acid-base reactions, and if you have a strong acid and a strong base, they form a salt and water. So this is an example of a double replacement reaction. We have here a picture of soap, and soap is made from chemical reactions, and back in the olden days, your grandparents, or maybe your great-grandparents now, would have mixed the fatty acid from their animals that they harvested, and they would mix it with lye, which is a strong base, and they would make soap out of that, lye soap. So fatty acid plus lye, which is a base, they would make soap out of. So here is our word equation. Hydrochloric acid plus sodium hydroxide yields sodium chloride plus water. Types of reactions continued. This is the fifth type of reaction, and it's called a combustion reaction. And it has the general form of CXHY. The X and Y represent any number of atoms. And we call these types of compounds hydrocarbons because they got hydrogen and carbon, hydrocarbon. And you burn that in presence of oxygen. And if you have excess oxygen, you carbon dioxide and water. If it's not noted, if it's excess or limited, you could write either one as a product. But I will try to always tell you. All right, and then if you have, if you have limited amount of oxygen, you have carbon monoxide and water. And this is something that you want to try to avoid. For example, if you are cooking out on your grill and it's a rainy, cold day, don't pull that grill into the garage because you limit the amount of oxygen going into your reaction, and you can create some carbon monoxide, which is a toxic gas. You should have a carbon monoxide detector in your house. If you have a attached garage, or if you burn any kind of fossil fuels like a fireplace or maybe a gas heater or something like that. And that would warn you to the presence of carbon monoxide, so you could vent your house and find the problem before you have a problem of becoming very sick, and it can also result in death. We have some examples here of hydrocarbons being burned. We have an example here of hydrocarbons being burned in the presence of oxygen. This is octane. This is a hydrocarbon that's in gasoline. And this is propane. This is in water heaters. It's also the gas a lot of people use to grill with. You have propane tanks to grill. And we'll learn how to balance these types of reactions in the next recording. So this is the end of the first recording on chemical reactions. Again, what I hope you're able to do here is recognize the different types and maybe talk a little bit about the importance of these in our everyday life. Looking forward to seeing you in the next recording.